Good evening, my 1100 warriors. Welcome to lecture number 4 of moving fluids. We have spoken about static fluids. We have also talked about Bernoulli's principle for moving fluids. We have talked about streamlines. We have spoken about ideal fluids. How about introducing to viscous fluids, the non-ideal characteristics? All with me, Shreyas, your physics master teacher, your captain for this channel. Welcome aboard, all my lovely warriors. And those of you who do not know me, I head the physics department, JEE division at Vedantu, and I have been teaching for almost more than a decade. And because of my love for teaching, and almost I got full marks when I wrote my JEE examination. So, I'm here to spread the joy of learning to all the states, to all the countries, right over here on your favorite channel, JEE Enthuse, the dedicated English medium channel for all the students aspiring to crack all the competitive examinations. So in today's class, what we are going to do is we're going to talk mainly about viscosity. So we're going to talk about what is viscous force, what does it depend on, and we are also going to see the Newton's law of viscosity. And yes, we are going to see this interesting number, magical number called as the Reynolds number. And we are going to see Stokes Law and the application of Stokes Law in terminal velocity, where we are going to see what's the final speed of anything which you drop in air. Because it does not continuously accelerate, eventually it acquires certain speed called as the terminal velocity. So welcome aboard, all my warriors. Hi Hema, Vasu, Ishpreet, Arvindam was waiting for me. Thank you Ishpreet for the lovely hearts. Hi, time for craft. Shivji, good evening. I'm very good, Arvindan. Hi Suchi Mama, I hope your exams went well. Hi Henish, welcome Abhishek. Hi Shubham, good evening my lovely warriors. And a big thanks for all of you who have already smashed the like button, and thank you for also hitting the subscribe button, because it means a lot, and only when you hit the subscribe and the like button does our channel get promoted by YouTube to other students who are still unaware of our channel. Not just that, you too will be shown all our videos, and there is a chance you might miss the video, you might miss our classes just because you have not liked and hit the subscribe button. So make sure you do both, because that's how the YouTube algorithm works. So also let's have a quick look of all the students who have given the answer to the homework questions. So every lecture I ask you certain questions towards the end, and many of you already have posted the answers. So in my previous class of Bernoulli's principle, this is what it was. And you can already see Harita, very good, Chandan, Ishpreet, wow, Ishpreet has really enjoyed the session. Thank you Bacha for that lovely comment. Very good Ritik, and I'm going to reply to your query as well. Don't worry, that's why I'm not yet liked or given the heart, but meanwhile I'll just give you one like and one heart. I will definitely reply to your comment. Very good Sushila, Ankit and Thirumurgan. Very good my lovely warriors. Make sure you keep posting all the answers out here so that you can come in the Hall of Fame in the next class. Well, so I hope your examinations are about to be over by now, and make sure whatever classes you have missed, you watch the replay of those classes. So yes, chess and football, you can definitely crack it. And Harikesh, I'm so glad you put in your full efforts. And don't worry Bacha, we have another term to crack, and stay with me, we're going to crack it together. Hello Abhinav. Hello Mani, let's begin. Now look at this yummy animation. This is honey, and the moment you talk about things like honey or sauce, what's the first thing that comes to your mind? Hello Saja, hi Jayavant. Yep, that's honey. Viscous, correcto, perfecto. So it's viscous, it does not flow. Look at that way it just stays there. But if the same thing was liquid water or some juice, then I know it's going to just flow off. What is that thing which is holding it together? I think it's got to do with molecular forces. I think it's got to do with the bonds of the molecules of honey. Maybe certain bonds are strong and they are hard to break, so they stick together. It's sticky. But non-sticky objects like water might just flow. And it also might depend on the density. Like, if the molecules are very heavy, it might be difficult for them to cross each other. It might be difficult to slide over each other. It might be difficult to, gather that momentum and, slide and, flow everywhere if it is heavy. That's what it is. So viscosity is a property of all the fluids, not just liquid. It's a property of all the fluids, and it gives rise to some kind of loss of energy, and it happens only because of the molecules' shape, size, and their bondings. How bonded they are, how heavy these molecules are, what is the structure of these molecules, will they hit, will they get stuck, will they get entangled with each other. All these things together decide the viscous nature. Viscous nature means how badly it's going to cause some loss in the energy while flowing. If it's going to suck away all the energy, all the kinetic energy which you give, so it's not going to flow because it has absorbed all the energy, like in the case of honey. But in case of water, hardly any energy is lost, so it will flow freely. The kinetic energy is conserved, like you can see. Yep. So Sudarshan, it will be approximately 1.5 hours to 1 hour 45 minutes. So the molecules tend to slide, they tend to make bonds. That's what causes viscosity. And one of the good examples where viscosity plays very important role is over here in engines. This is a cross-sectional animation of an engine, of a scooter or of a car. Understand, when you have two surfaces, let's say for example this surface and let's say this surface, when they slide with respect to each other, when they slide, do you hear that sound? Do you hear that sound? What is that sound coming from? Because of friction. You rub your hands. Did it get hot? Just rub your hands and see, did it get hot? Are you hearing the sound? Where is it coming from? Friction. That's two solid surfaces in contact. Now, when you have moving parts like this, and if they continuously make that noise, and if continuously they generate heat, and they continuously lose out energy, that's a very bad thing. You obviously do not want that. So that's why what you do is basically you add some lubricant, you add some oil between the two surfaces. The moment you add some oil, when you add some oil, what happens? There is a layer of liquid formed. That layer will make sure that the two surfaces slide smoothly. So oil is generally added. Now you might think that when oil is generally added in moving parts or in lubrication, sir, oil is very thick, sir. Oil is very, sticky, sir. Or the oil is not so flowing as water. But let me tell you, at normal temperature, oil might look sticky or might look viscous, or it might look like a drag, as if it's taking away the energy. But the moment it becomes hot, the moment the engine starts gearing up, it starts revving up and it becomes hot, it becomes so fluidic, it becomes so non-viscous that, it acts like a very good lubricant. Plus, the boiling point of oil is much higher than that of water. So it does not even evaporate, and that's the reason why you use oils as a lubricant. Exactly like a mustard oil or coconut oil. Perfecto. Yep. So, yes. So, Suchimama, yep. So when you have a ballpoint pen or a gel pen, yes, the viscosity of that gel will also decide, how nicely, smoothly you can write it. Yep. Mechanical properties of liquid and fluid mechanics. Srija, a part of fluid mechanics is mechanical properties of liquid, like viscosity and surface tension, which is a part of mechanical properties of liquid, can also be categorized under fluid mechanics. Got it. Very good. Hi Vivek, good evening. So what is viscosity? It's the property, it's an internal property between the molecules, and the layers tend to slide over each other, they oppose the motion, and because of which some energy losses might occur. If I ask you, is viscosity going to create a conservative force or non-conservative force? What is your answer, guys? Because this viscosity is going to create a force which is called as the viscous force. Sometimes this is also called as the drag force, viscous force, or even the drag force. If I ask you, is this viscous force conservative or is it non-conservative? What should be the correct answer? What do you think? Is it conservative force or is it non-conservative force? Chess and football, we are going to solve problems as soon as I complete this bit of theory. Yep. Will these type of objects evaporate? Well, Saja, it depends from material to material. Oil will not evaporate so easily, water will. Depending on the liquid, it will have different boiling melting points here. No, it is not conservative. In fact, it is non-conservative because it is a friction-like force. A friction-like force. And whenever you have viscous force, then understand that the mechanical energy is not conserved. Mechanical energy is obviously not conserved. Why is it not conserved? Because there will be some loss. All those forces which cause loss in the mechanical energy will be non-conservative. Makes sense, my warriors? And it is not independent of the path, it depends on the path. So if you slide it like this, it will do different work. If you slide it like this, it will do different work. So because you are traveling more distance, so more amount of liquid will be disturbed, more amount of resistance will be encountered on a longer path. So it depends on the path, hence non-conservative, and also mechanical energy is not conserved. Everybody clear till this point? Yep. Yes, Saja, let's not worry about plasma. Yep, let's focus on liquids. Yep, it is a fourth state of matter. Definitely, you have heard it right. High viscosity means, is it more volatile? No, high viscosity means it is more like this. Look at this, it's like this. This is high viscous, highly viscous, more viscous force. Less viscous means flows, fluidic. It can flow very easily. Okay, fair enough. Now, I want you to see both these scenarios, how a liquid flows between two plates of maybe a glass or metals or two just surfaces, and how the liquid flows in a pipe. Just imagine you have one layer which is stationary, another layer which is moving, something like a river. River, you have two surfaces, or maybe you can think of a canal. Okay, one of the surfaces is at rest and the other surface is moving. Or you have two slides and there is liquid trapped between them and you slide the surfaces. This is how it looks like. This is the liquid which is trapped. One of the layer is moving with the lower part, the other layer is moving with the top part. You can see each layer has different velocity. The layer which is in touch with the bottom part has negligible velocity. The layer which is in contact with the topmost part is moving with the topmost layer. Do you see that? Yep. So laminars, you can see layers of fluid being flown over here. Whereas in case of a pipe, it's completely different. It's a hollow pipe. It's a cylindrical pipe. All the parts which are in touch, which are in contact with the outermost surface of the pipe will be hardly moving. The central part will be moving very fast. So these layers, these two layers, they are in contact with the periphery, the outermost surface. So you can think of concentric cylinders. The innermost cylinder will move fastest. The outermost cylinder will be held by these two surfaces of the pipe. Whereas as you go inside, they are easily able to slide over each other. Hence they have maximum speed. Does it make sense? Yep, Sushi Mama, perfectly. You said it right. Sure. Vivek, you're going to get the PDF on the new Telegram channel. Make sure, my warriors, you join the new Telegram channel, because on the old Telegram channel, we are not going to post the PDFs anymore. It's going to come only on the new channel. So in case you haven't joined it yet, make sure you join it. Now, this brings us to something called as the velocity gradient, because you just saw the velocities of different layers are different. So it's good now to define something called as the velocity gradient. Just imagine that you have certain layer of fluid, let's say I call it layer 1, and let's say I have another layer, okay, like this, let's say I call it layer number 2. Layer 2, for example, has velocity v. It has velocity v, and the adjacent layer has a different velocity v plus delta v. What is delta V? It's the relative velocity between the two layers. So what is delta V? It's the relative velocity between the two layers. Now just imagine that the separation between them, the distance of separation between the two layers, let's say is delta H or delta X, whatever you want to call it. The separation between the two layers is delta X, delta Y, delta H, whatever you want to call it. I define a new term called as velocity gradient. Velocity gradient. Gradient, if you remember correctly, is a word used for derivatives when differentiated with respect to distance. When you differentiate with respect to time, it's dv by dt. Then it is called as rate. Rate means derivative with respect to time. Whenever you use the word gradient, it is always differentiation with respect to distance. So velocity gradient is rate of change of, okay, rate of change of the velocity with respect to the distance between the layers. So essentially it is dv by dx, or I can just say delta v by delta x. If somebody asks you what is the unit for that, well, it is meters per second divided by meter. So that will just become per second. I hope you can see that. Meter per second by meter, right? So only per second or second inverse will be the unit for velocity gradient. It tells you how quickly the velocity changes with distance. If the velocity gradient is more, what it means is that there is rapid change of velocity in a small distance. But if the velocity gradient is less, then it means the velocity hardly changes with distance. So this is less velocity gradient, this is more velocity gradient. Is that now understood, my warriors? Yep. So if you want to study for JEE Mains, Mr. Abid, you should study from 11th standard bacha, because 11th standard lays the basics for 12th standard for sure. Surface tension, Sudarshan, will be done after this. Okay, after viscosity, next class is exactly surface tension. Now there are two kinds of velocity gradient, but you should be very happy in JEE we have only the first kind. Now what are the two types of velocity gradients? One velocity gradient is where you can see the velocity changes uniformly, meaning if you draw one line like this, it becomes a straight line. If you connect all these arrow marks, it becomes a straight line. That is called as uniform velocity gradient. Non-uniform means if you draw the velocities like this, then like this, then like this, then like this, you will see if you connect all of them, it becomes curved. So this is non-uniform. This is non-uniform velocity gradient, but in JEE syllabus we do not have it. Okay, you will study it if you take aeronautical engineering or naval architecture or chemical engineering or automobile engineering. Yep, then you will be studying all of that. But for now, in JEE, this is good enough for all us. Okay, last thing that I want you to also understand, that now that we have spoken about velocity gradient, I remember sliding action is related to shear. Do you remember this? Slide is shear. That's another word for shear. You slide another object, the brakes, bonds, and it just slides over it. It moves over it. So think about it. In solid mechanics, when I had one layer and it moved here and it moved by, let's say, x distance, and let's say the separation between them was something like, I don't know, maybe it moves by L, let's say. Okay, let's say it moves by L, doesn't matter. And let's say this separation was, let's say, x. The strain was given by how much it moves upon how much was the separation. How much it moves by how much was the separation. Do you remember that? Now, over here, it has moved, but per unit time. Just think of it this way. The topmost layer moves with the relative velocity delta v. Delta v is nothing but not the distance, it's the distance moved per unit time relative to the lower layer which is separated by a distance delta x. So this thing which is there, that ratio delta V by delta X, it's not the normal strain, it's called as the velocity strain or strain velocity. This is called as the strain velocity, which is also nothing but the velocity gradient. This is velocity gradient. When you have distance by distance, it is called strain. But when you have distance per unit time by distance, then it is called strain velocity, which is nothing but, simply put, velocity gradient. Yep, Vignesh, I am covering full of viscosity. Is this very important for JEE Mains? Yes, it is. Every year you will have approximately one question. Yep. So you cannot take a risk. And it's an easy chapter. If you attend today's class, 4 marks guaranteed. This is how you slowly put in your pocket 4 marks. Many students do not know how to score marks. See, it's not by studying for one night. It's when you study whole year. One chapter will keep on fetching you 4 marks. You just need to keep on collecting it and start putting it in your pocket. And slowly you will realize, oh, now I have 20-40 marks in my pocket. And that's how your scores improve. Remember that. Fair enough, I guess. So I hope you understood what is velocity gradient, and I've just wrote about strain velocity, and I've also spoken to you about non-uniform velocity profile, which is not a part of JEE syllabus, so ignore this, but you should know what it means, and this is what we are going to talk about. So here's the first question on your screen now. Here it is. The top layer of 2 consecutive layers is moving with 6 centimeters per second, and the bottommost layer is moving with opposite direction with 2 centimeters per second. If the perpendicular distance between the 2 layers is 0.1 centimeters, then the velocity gradient will be, okay, these units seem to be wrong. This should have been per second. Ignore the units. Just ignore the units. This should have been per second, my warriors. Okay, let's see how many of you can Zozo, see, like that there will be many topics, Zozo, so you can start leaving all the topics. I mean, then you can leave electromagnetic waves also, because there is no weightage. JEE Mains never gives you weightage of this topic. It's just by the trend. And then you can also start leaving, you know, even errors and measurement. There is no weightage for that. Maybe one question, sometimes 2, sometimes nothing. Then you can also leave calorimeter, because then sometimes there are no questions on calorimeter. Sometimes, you know, you don't have questions on maybe prisms. Then you will leave that. Sometimes no questions on optical defects. You will leave that. So that way we'll start leaving all the chapters. So not important. So you will leave everything. So that's the exact wrong strategy of coaching. Many coaching institutes do that. See, we can do that when you are at the last moment, you have not studied for 2 years, and then some student comes and tells me, sir, what do I study? Then I'll tell them, not important. But right now, you have a lot of time. Don't waste it. And listen to me, this is how you're going to score marks. Okay, B. All right. Here we go. Let's see whether it is correct or wrong. And the topmost layer is moving with 6 centimeters per second. The bottommost layer is moving with 2 centimeters per second, and the distance between them is 0.1 centimeter. So strictly speaking, with respect to the bottom layer, the topmost layer is moving with 6 plus 2. So this is the bottom layer, and the distance of separation is 0.1 centimeter. So 6 plus 2, which is 8 centimeter per second. So hence the velocity gradient will be del V by del X, change in the velocity from one layer to the next layer, from one to the other, which is 8 centimeters per second, divided by 0.1 centimeter, that's 80 per second, or second inverse. So this should have been second inverse, so I think it should be option B. Done. Perfecto. No, delta V is not 4, it is 8, bacha, because one is going this way, other is going this way, relative velocity. With respect to this will add, it will not subtract. Be careful. Aishwarya, no problems, bacha, join in. Hi Kalyani, good evening. My timings have changed to 7 o'clock, my warriors. Alright, so that's my new timing, and the answer is 80. Two things going in the opposite direction. Mr. Abid, if you join the JEE crash course even now, the videos are not recorded, the videos are live. Alright, so they will teach you from 11th standard unless you join the older crash batch. But yes, if you join the fresh crash batch, which has just started this Monday or which is going to start the next Monday, then everything will be live and they will teach you right from 11th standard and then go to 12th standard and all of these things. Perfecto. Okay, so here's the next question. Let's go to the next one coming up on your screen. Which liquid is viscous? Which one is not viscous? Look at the layers. This is a pipe and this is also a pipe. Look at the streamlines and gauge which one is viscous, which one is non-viscous. Think about it closely. Figure it out. One of them could be viscous, one of them is non-viscous. A is viscous or B is viscous. Think carefully. Okay, Vivek, I know my mic is very good. You can hear everything. Believe me, if I stay silent, you can start hearing whatever is going on outside and you can see that. Hello Sundar. Okay, so did you hear everything outside? Yep. Okay, so B viscous, A non-viscous, A non-viscous, B viscous. Okay, so that's what most of you are saying. That's what it is. I am very good, Kalyani. Okay, I'll tell you what. When the layers slide and there is no relative motion, that means there is no drag, there is no pull-push between the layers. If there is no pull and push between the layers, then it is not viscous. But B, yes, there is relative sliding because one will try to move fast, the other will try to pull it back because the other layers are at rest, which is in contact with the periphery of the pipe. So the outermost layers are at rest because they are being pulled by the outer surface. This layer will pull this layer will pull this layer. So there is relative sliding because of the pull and push, which is the viscous force. So hence, B is viscous, A is non-viscous. Perfecto. Perfecto. Yes, A is not viscous, B is viscous. This is how you can distinguish between, viscous fluid and non-viscous fluid. If it is more viscous, then this gradient will be more. You are going to see that. This gradient will be more. It's going to extend. If it's less viscous, there will be hardly any difference between these arrow marks. They might just show a tiny bump. More viscous, the bump will increase. That's how it is. Zozo, watch my lectures in Nurture. It is there. Playlist. Watch my playlist. That's how. Very simple. 6 classes to 7 classes. Everybody knows it. Nurture playlist and you are done. You're sorted for life. Okay, just watch it. Wow, what a beautiful simulation. I think this is Fevicol. Okay, that Fevicol liquid. Lot of wastage. This is oil, so fluidic. And I think this is more like maple syrup or honey. I love maple syrups, by the way. If you haven't tried maple syrup and you prefer honey, then maybe you should give it a try. Definitely try out maple syrup with breads, with pancakes. Next time you go out, it's amazing. And how many of you are maple syrup lovers versus how many of you are honey lovers? You just probably can have a vote out right over there. All right, so let's talk about a law now which relates viscous force and will give you something called as the coefficient of viscosity. So here it is. These are the layers of fluid. They are sliding with respect to each other. Each layer, when it slides with respect to the other, so there will be some viscous force. So imagine these are the layers. The separation between the first and the last layer is L. The separation between the first and the last layer is L. The area of each layer which is sliding is A. There is also a velocity gradient. The bottommost layer is 0, topmost layer is V. So I can quickly find the velocity gradient as well. And remember, if I have to push the topmost layer, I'll have to apply some force. If I don't apply the force, it will stop. It will go like this and stop. If I apply the force only, then it will move. That means there is a resistance force. So the resistive force was given by Newton. And here is how it is. Okay, Arun, making you hungry. Don't worry. We're going to end the class after 1 hour and then you can definitely demand your mom for honey and maple syrup. But I doubt what you will get. You might get one slab or you might just get one angry look, shut up and sit there and study. I don't know what it is. Okay. And what do we have over here? Okay, so one layer to the next layer, we have velocity gradient, fair enough. So what did Newton do? He found out velocity gradient for different fluids and for the same fluid for different velocity gradients. So that was delta V by delta X. He also saw what is the area of contact between the surfaces, which is basically A. He also found out what is the viscous force which is there between the layers, which is F, which is also sometimes called as the drag force. And then he found out this viscous force is directly proportional to the area, and it is also proportional to the velocity gradient dV by dx. Hence, he came up with a constant of proportionality. So A and dV by dx will come over here as it is. That constant of proportionality is eta. That is a very important constant, just like you had coefficient of friction, which depends on the surfaces. Same way this eta, which is coefficient of viscosity, it depends on the material, basically the liquids. So I'll just put over here, it depends on the fluid. Not just that, it also depends on one more thing, and that is the temperature. We're going to see how it depends on temperature in the next slide, but for now, remember it depends on the temperature as well as the fluid, which fluid you are using. That's how it works. Very good. All right. Vivek, it is called Maple, M-A-P-L-E, okay? Amazon pay order. Okay. Now, how many laws Newton gave? He gave many laws, Sundar. That's what Newton is. Yeah, very good. So, don't get scared and don't get irritated by Newton. He's not going to get rid of you. You won't get rid of Newton. He's just going to hold you by his arms, and he's like the toxic relationship. He's just going to hold you in your arms and he's like, I'm not letting you go, no matter how much you try and run away. Okay, so be there. Now that we know that F is eta dV by dx, some of the books use this negative symbol. Don't get scared. Negative symbol just means that it is opposite. It is a drag. It opposes the velocity. That's it. Nothing else. So don't get scared by it. And the unit of viscosity, you can try it out by substituting all the dimensions. Force is Newton, area is meter square, dV by dx is per second. If you do the math, you will get it as Pascal second. You can try it out even now. Within 10 seconds you will get it. And the CGS unit is called as poise. That's something which you should remember. CGS unit is poise, and 1 poise is 0.1 SI unit. I'll repeat. 1 CGS unit, which is poise, is 0.1. You can do the conversion. 0.1 SI unit. Keep this in mind. Yep. So what are the things that we have learned? This eta, how do you pronounce it? ETA. Eta, okay? Like you have these variants of coronavirus, alpha, beta, gamma, delta, omicron. So this is eta. So the day you have eta variant of COVID, remember your life is gone for a toss now. Okay, so thankfully we don't have the eta variant of COVID yet. So are you happy about it or are you sad about it? All right, so let's move ahead to the factors which affect viscosity. All right, so Kalyani has already accepted Newton. Very good. That's a smart move. Moving to the factors. How does it depend on temperature? Well, so yes, Suchi Mama, it is. Eta or viscosity for a liquid behaves little bit differently than gas. For liquids, when you heat it, it becomes more mobile, the bonds are broken, and because the bonds are broken, the attractive forces between the molecules go less, and because of which the viscosity will decrease. So when you heat a liquid like oil, you will see the viscosity will become less. That means it will become more mobile, it will become less viscous, and it will become more free flowing. But for a gas, things are completely different. When you heat a gas, then already there are no bonds because molecules are very far. Then the molecules will have more kinetic energy. They will start colliding with each other. They will start hindering each other. It's like a crowded platform, a railway platform, and you ask everybody to run. There will be a stampede. You will collide with each other. So because of that stampede, the viscous force will increase. There will be a lot of resistance, air resistance will increase. So that's what happens. So with temperature, remember for gas, viscosity, where is it? In the case of gas, when temperature increases, viscosity increases. Whereas for a liquid, when temperature increases, viscosity decreases. Very, very important points. The first 2 points are very obvious. If you have more heavy molecules, density is more. Like for honey, viscosity is more. Viscosity is more. But for less dense liquids, you will see the viscosity is generally less. Okay, Rakesh says, Howrah railway station. Yes, I have been there and I know what a mess it is. Be to the other railway station and then you'll be like, sir, I don't want to travel in trains anymore. Okay. Yes, Prakash has seen his mom heating castor oil and then it becomes more fluidic. Yep, very true. And you apply it on your body for your joint pains, I guess. And here is our question coming up on your screen. Well. A metal block of area 0.01 kg mass via a string, and it is connected over a massless, frictionless, I think that word massless shouldn't have been there because the pulley has mass, over a frictionless, ignore this words, okay, over a frictionless pulley 0.01 kg as shown in the figure. A liquid over here you can see, and a film thickness of 0.17 millimeters is placed between the block and the table. This is the table. When released, the block moves towards the right with a constant speed of so much. The coefficient of viscosity is how much? G value should be taken as 10. Here is what you need to do. First, understand this pulley is frictionless. The rope is traveling over it. So even though the pulley has mass, it really doesn't matter because the pulley is not even going to rotate. It's frictionless. The rope is just going to slide over it. So this mass over here, I don't care. Make sense? Frankly, I really don't care because the pulley and the string are just going to slide over each other. It doesn't matter. Next thing, this thing over here is moving with a velocity. How much velocity? It's moving with a speed of 0.085 meters per second, and this is constant. Think if this is constant, what is the acceleration? Come on, my warriors, answer it in the chat box. If the velocity is constant, then what do you think is the acceleration of this body? Come on, my warriors. Yeah, very true, Sushi Mama. Malls during a sale and card festival. And yeah, thank you, Kalyani, and glad you're live. Class 12 live will come tomorrow, Nandini, and it's the best thing to always hit the bell icon and also join the Telegram channel link so that you do not miss any of the further classes and also know about the updated schedule. I have already posted, but still, just join the Telegram channel and hit the bell icon down there so that you get notified in advance. 0, perfect. If acceleration is 0, that means the tension force over here must be balanced by some other force. Which force will balance it? Friction? Nah. But instead of friction, we have another force, and that is something what we have studied right now, and that is viscous force. So there is the viscous force which is going to oppose it. And this tension right over this string is passed over here. This tension will be this tension, and this will be nothing but mg. Now comes the challenge. What is this viscous force? Viscous force will be tension. But what is tension? Tension will be mg. So I just got an equation. The viscous force will be equal to tension, which is also equal to mg. But by Newton's law, it is eta a dv by dx, and this m is m and this g is g. What is dv by dx? That also I can find out. Telegram link, Nandini, is there in the description box below, and check it out. It's just there. Just go down. It's there. Telegram channel link. You just need to scroll down. Eta is what we need to find. Area I do not know. dV and dx also I need to put it. Let's see. Eta, I don't know. Area is 0.1, so I'm just going to put 0.1 over here. dV, remember the topmost layer will move with 0.085, the bottommost layer will be at rest, and the distance between them will be 0.17 millimeter. This was 0.085 meters per second. So 0.17 millimeter is 0.17 into 10 to the power minus 3 meter, which is 1.7 into 10 to the power minus 4 meter. That's the separation between them. So dV will be 0.085. 0.085 is nothing but 8.5 into 10 to the power minus 2 meters per second. 8.5 into 10 to the power minus 2. So dV will be nothing but 8.5, okay, into 10 to the power minus 2 divided by dx. What's dx? It's 1.7 into 10 to the power minus 4 is equal to mg. What is m? M is 0.01. So 0.01 into g is nothing but 10. Let's see what happens. 0.01 into 10, 0.1. 0.1 here and 0.1 here, does it cancel out? Just check this out. I think this 10 multiplied with this gives you 0.1. This 0.1 and this 0.1 cancels out. 10 to the power minus 2 and this 10 to the power minus 4, it will become 10 to the power plus 2. Okay, fair enough. Or you can just do one thing, just put 10 to the power minus 2 over here, because I can then take it on that side. So I think I know what eta is. Eta will be, 1.7 and 8.5. I know that also goes. This goes 5 times. This goes 5 times. So basically what I have got is nothing over here. So it will become 1 by 5 and it will go over there and it will become 10 to the power minus 2. Right? So 1 by 5 is 0.2 into 10 to the power minus 2. So this will be 2 into 10 to the power minus 3. Is that there? Yes, it is. Perfecto. Yep, Gaurav, you can just go back to the playlist. You can just go to the past videos. You will see lecture number 3. Today's lecture is lecture number 4. Okay, I think lecture number 4 or 5. Yep, very good. I hope there is this clarity on how to solve the question. And don't worry, Murugan, if you are not able to see it, I'll post the link again and you can reply to or put up a comment after the video ends and I'll reply to your comment, okay? After the video ends, not now. You cannot post a comment when the video is going on. Perfecto. No, this is not the last lecture. We are going to have more 2-3 lectures, but that will be on surface tension. So surface tension also needs to be done. So we're going to have on that. So fluid dynamics encompasses all the chapters, like I have told in the first class of fluid dynamics. So we're going to have statics, dynamics, viscosity, surface tension, drops, capillarity, everything under one section of physics. Yep. Now here is the next one. There is a thin square plate of side 10 centimeters. This is a top view. It is pulled with a constant speed of 3 centimeters per second in an oil. The width of the oil is 2 millimeters. The square plate is placed symmetrically as shown. Assume that the layer of the oil at the end is negligible. Coefficient of viscosity is 150 points. Find the horizontal force required to move the square plate with constant velocity. Let's see how to do this question. First, let's visualize what is happening. It is mentioned, assume the velocity of layer. Let's read this. Layer of oil which is towards the end is negligible. This is what is mentioned. That means this point has negligible velocity, then the velocity increases slowly. This is how the velocity gradient looks like. This is how the velocity gradient should look like. Slowly the velocity keeps reducing and then again it becomes 0. Now the layer which is just in touch with the metallic plate, remember this is the plate, these are the two boundaries, is moving with a certain speed. How much? 3 centimeters per second. So it is moving with 3 centimeters per second, which you can also write it as 3 into 10 to the power minus 2 meters per second. Fair enough. The distance between the distance of that oil column is 2 millimeters. So this entire thing is basically 2 millimeters. So I know one thing for sure, this distance is 1 millimeter, which is 10 to the power minus 3 meters. Even this distance is going to be 10 to the power minus 3 meters. Why do I need these? Because I need velocity gradient. Last thing, the viscosity is 150 poise. That means eta is 150 CGS units. Remember, 1 CGS unit is 0.1 SI unit. So this will be 150 into 0.1 SI units. So which is 15 SI units. Does it make sense? I have given you the conversion factor just some time back. Alright, perfecto. Yep. Now, the last thing is, what is the force required to move the plate? So, here is the last, trick. See, to move it towards the right, obviously you are going to apply a force here. How much will that force be equal to? Obviously, it should balance the drag force. But there is the catch. The catch is, it will not be equal to the drag force, but in fact, 2 times of the drag force. Can you think why? How many of you got it? Why it is 2 times? Let me know in the chat box. Yes, Ankit, every chapter is important. You have time. Now is not the choice to think about which chapter is important and not important. You have 3 to 4 months. There are 2 drag forces, one on this side and one on this side. Thank you, Devi Kodela. Means a lot, bacha. Thank you so much. Yep, a big thumbs up to all the students learning from AP2. Alright, so there are 2 drag forces, one drag force or one viscous force here and one viscous force from this side of the fluid. Both the sides fluid is going to pull it behind. Okay, 2 sides. It's like a plate. It's moving like this. So this side of the fluid will pull it. This side of the fluid will also pull it. So that's why 2 drag forces. Make sense? Yep. No, it's not because it is equal and opposite. It's because there is fluid here and there is fluid here. If this fluid was not there, then it will be just 1. But if this was not there, then also it is 1. Both are there, then it is 2. I hope this is clear. Okay. So that is the reason why the pull will be 2 times of Fv, which is 2 times of eta A dV by dx. So 2 into, what is eta? Eta is 15. What is area? Side length is 10 centimeter. So that means area will be 0.1 whole square, which is 10 to the power minus 2 meter square. So makes sense? 10 centimeters is 0.1 meter, 0.1 square is 10 to the power minus 2. So it is 10 to the power minus 2. dV will be this minus this, so 3 into 10 to the power minus 2 divided by distance, which is 10 to the power minus 3. 15 2s are 30, 30 into 3, 90. So I just got 90 over here. 10 to the power minus 2, 10 to the power minus 2, 10 to the power minus 4. This 10 to the power minus 3 goes on the top, it will become 10 to the power 3. So check this out. So 10 to the power 3 into 10, 10 to the power 4. So I think it should get 9. Yes, so 9 Newton, that means option D is the correct answer. Perfecto. Adepu, you are not going to have 90, bacha. Yep. Perfect. Understood? So the catch was this 2. If you don't put this 2, you will get exactly half the answer. Hello, feel the music. Join in, bacha. Got it? Shall we move on to the next few questions? Are you guys enjoying this session? And I hope you have already smashed the like button. Remember, the Telegram link is there in the description box. So I'll just show it to you before I go ahead. So when you go to the description box, it should be somewhere over here. Join our Telegram channel. So when you click on this, you will see the link, JEE Enthuse English. This is a new channel. Remember, the old channel will be deactivated soon. So make sure you shift yourself to the new channel. Also, you will find other links for joining crash course, for joining the 11th standard crash course, and also the 2-year course for 11th plus 12th standard. And also KVPY classes as well. The link is all there in the description box. If you're not able to find it, don't worry. I'll show it to you towards the end of the class because there is hardly a month for the KVPY examination and I'm pretty sure you want to prepare for it. Now, let's move ahead. Let's talk about, what is laminar flow And how do you distinguish it from the turbulent flow? Few lectures back, I had shown you what is turbulence, and you might have experienced turbulence when you're traveling in an aircraft. Yes, it is very important. How many of you have experienced turbulence? No problem, Suchi Mama. Yes. So Nandini, I'm going to continue with light waves, and then I will start either ray optics or modern for 12th. So turbulence is basically unexpected, journey of wind. When you expect it, you know how to control it. When it is random, you cannot predict the motion, then it is called turbulence. The good example of that is over here. This is laminar flow. Look at this. In a pipe, the layers of the liquid, slide with respect to each other. There are layers formed. One layer slides over the other layer. It's a beautiful flow like this. But in turbulent flow, look at the same particles. Look at this. Crazy, right? It's completely unpredictable. So there is a velocity after which the flow becomes turbulent. If you gradually pass the liquid, it will not be turbulent. It will flow smoothly. It will be very predictable motion. But the moment you pass that same fluid at a very high velocity, then it's like congested. See, I will give you a simple example. You should always feel physics. I tell you, your entire class should pass through the corridor in 1 hour. You'll be like, so chill. You'll be like, hey macha, come, let's go together. What is your story? What did you do in the night? You are going to, walk peacefully in that corridor, right? Right? But if the teacher tells you all of you in the classroom should exit the corridor within 30 seconds, there will be crazy madness out there. Like, who cares who is besides me? You're just going to run over each other. You're just going to make sure you exit the corridor. So there will be a lot of unpredictable motion. Not predicted. So that's what happens. So there is a critical speed after which a streamlined flow becomes turbulent. And we can find that out. And that's what I want to show you. And there is a magical number for that. And that's called as the Reynolds number. This Reynolds number was given by obviously Reynolds. And he found out that this magical number can predict whether this fluid flow is steady or whether it is going to be turbulent. Exactly. That's what he found out. Yep. How many of you have heard about this? Does it happen if you add water fast on the plants? Yes, definitely it can happen to the water if you add really fast on the plants, definitely. Yep. So like gas molecules, yes, SK. So here is the thing. He saw that this magical number, if it is less than 1000, then it is laminar and steady flow. Okay, it is steady, it is predictable, that magical number. But if that magical number is more than 2000, then the flow becomes turbulent. Then you're like, sir, if it is less than 1000, it is steady. More than 2000, it is turbulent. What if it is 1300? What if it is 1800? Guys, then it is not predictable. Sometimes it shows steady behavior, sometimes it shows turbulent. You cannot be for sure that whether it is steady or turbulent. There is an ambiguity over there. Thank you, Likit, so much. Hello, good evening, fine arts. So what did I say? Below 1000, it is predictable. 100% I know. Yes, it goes like this. Above 2000, if it is 2100 also, I know it's going to be random. If it is 1600, 700, 800, then sometimes it goes properly, sometimes it becomes turbulent, unpredictable. And what is this Reynolds number? It is rho v d by eta. This is your Reynolds number. What is rho? That is density. This is density. What is v? That's the velocity of fluid. Okay, that's the velocity of fluid. What is eta? It's the viscosity. Viscosity, right? Coefficient of viscosity. This d is basically the diameter. This is the diameter of that particular pipe. That's how you get it. Got it, my warriors? Can we do some questions based on Reynolds number? Okay, so I'm just going to give you the theory for that. Again, Reynolds number is a magical number found by experiments. It is rho v d by eta. Rho is density, v is velocity, d is diameter of the pipe, eta is viscosity. And the Reynolds number gives you an idea whether it is turbulent or non-turbulent. So if it is less than 1000, it is laminar. You can predict it. More than 2000, it's for sure turbulent. Between 1000 and 2000, it's intermittent. That means sometimes steady, sometimes not steady. If it's greater than 1000 but less than 2000, like I said, Suchimama, it is not predictable whether it is steady or unsteady. Okay, so that's how it works. Hi Daya, thank you so much. You understood my warriors. Okay, so Surya, definitely I will help you. Just leave a comment after the session ends. I will comment on your comment and I will give you the link. Or you can also ping me on my Instagram handle, which is Shreyas_Vedantu. Here is the next question, bacha log, coming up on your screen. All right. Yep. So yes, Surya, when you use my coupon code, you will be directed to the new batch which is starting. Those are all live classes. The recordings will be there once the classes are over. So as soon as the class gets over, you get the recording so you can watch it whenever you want also. Both options are there for you. So water from a pipe is coming at a rate of 100 liters per minute. The radius of the pipe is 5. Reynolds number is of which order? And the density of water is this much. Coefficient of viscosity is also given. So let's try to figure out what is the Reynolds number for this case. So what is the formula for Reynolds number? Reynolds number is nothing but rho velocity into d divided by eta. Rho known. Eta, yes, coefficient of viscosity, milli PS. PS is SI unit. Okay, I know it. Diameter, radius is known, so diameter is also known. Speed, I do not know because volume flow rate is given. So in the question, volume flow rate, the volume flow rate is given to be 100 liters per minute. Now, once you know volume flow rate, first try to convert it into SI units because I want to find the speed. Without speed, you cannot find Reynolds number. I hope you guys get it. Yep. Okay. So Surya, don't worry, you can also join the 20th December batch. 20th December is starting tomorrow, day after tomorrow, well, Monday. You can join it. Don't worry, you can always change it. I'll tell you how. Just ping me on Instagram or leave a comment. Okay. Now, 1 liter is 10 to the power minus 3 meter cube. 1 liter is 10 to the power minus 3 meter cube. So 100 liters will be 100 into 10 to the power minus 3 meter cube. And this is per minute, so into 60, so this will be seconds. So 1 0 goes. So this, yep, I can just put it over here. Yeah, let me just keep it as of now, 10 to the power minus 2 by 6 meter cube per second. Rate is speed into area. Remember, it is speed multiplied by area of cross section. So speed into area. Area will be pi r square. So pi into r square. What is r? R is radius. Radius is 5 centimeter. So 5 into 10 to the power minus 2 square. Perfect. Now let's see what do we get. So this will become v into pi into 25 into 10 to the power minus 4 is equal to 10 to the power minus 6 divided by, 10 to the power minus 2 divided by 6. So let's see what and all cancels. This goes as 10 to the power minus 2. Okay. And 10 to the power minus 2 is nothing but 1 by 100. Perfect. So 25 goes with 100 4 times. 4 and 6 also goes. So divided by 2, divided by 2. So this is how it looks like. So basically I will get velocity is 2 goes on the top, pi comes below, 2 by 3 pi meters per second. See if this makes sense, all of you. See if this makes sense. Volume flow rate is how much volume flows per unit time. And in fluid dynamics, the first lecture I told you volume flow rate is nothing but area. Volume flow rate, volume per unit time is area into velocity. So this is the formula that I have used. Area into velocity. A1 V1 is A2 V2. Remember continuity equation. So that's where I had told you about volume flow rate. Check this out. So that's where I got it from. Once I get velocity, I'll substitute it here and then try to solve the question. So rho is 1000, which is 10 to the power 3. Velocity is 2 by 3 pi. Diameter 5 centimeter into 2, 10 centimeter. So 10 into 10 to the power minus 2 divided by eta. So 10 milli. So 10 into 10 to the power minus 3. Okay, a lot of things are going to get cancelled. So let's see what and all gets cancelled. 10, 10 goes. This goes. So it will become 10 to the power minus 1. So once it goes on the top, it will become 10 to the power 4. So just check this out. If everything is fine, all right, just check this out. All right, so you have 2 divided by 3 pi. Just check this out, everyone. Perfecto. Cool. So yep, everything. Velocity is also given. Okay, diameter is 5. Yes, perfect. Okay, so this will become into 10 to the power 4. Now look at this. 3 pi. 3 pi means 3 into 3.14. That will be 9 point something, which is approximately 10. Approximately 10. Correct? 3 pi, think about it carefully. Yep, 3 pi is approximately 10. So 1 of the 10, or basically that 3 pi, and this cancels, so it will become 10 to the power 3. So can I say this is approximately 2 into 10 to the power 3? In fact, slightly more than that. Because 3 pi will be 9 point something, not exactly 10. So slightly more than 2000. Slightly more than 2000. So 2000 is basically 10 to the power 3, and definitely it will be turbulent flow, because this will be not exactly 2000, it will be slightly more than 2000. Does it make sense? Got it? So this is how you can predict whether the flow is turbulent or not turbulent, and you also, although it was not asked, but still we found it out. Yep. Yes, Arani, definitely you can crack, bacha. Definitely, you have a lot of time. Okay, you can definitely crack, but get to studies immediately after your bio exam is over. 10 to the power 3 and turbulent. Perfecto. Got it, my warriors? Shall we go ahead to the next one? And here we have Stokes Law. So, what do we have here? Stokes Law. We just found out that when layers slide with respect to each other, there is a drag force between the molecules. But when you have an object thrown in a liquid, that also will experience drag force. Like, for example, this car. This car. When it moves, the air around it will create viscous drag force. So if the car goes here, then there will be a drag force here. And the whole idea of designing a car, designing an aeroplane, designing a boat, designing an F1 car is all about making sure that the drag force is less for the given mass, given volume. Somehow making sure that the flow is streamlined. Each object has a different value of drag force. In JEE, we have only one object, and that is sphere. We don't have cube, we don't have cone, we don't have anything else. We just have one object, and that is sphere. And whenever you throw a spherical object, the amount of drag force is given by Stokes Law. This is only and only for sphere, and that drag force is given by, look at this sphere, it is thrown with speed v, it will experience a drag force. Opposite to it, that is given by 6 pi eta r v. Very important formula. Basically, the drag force is proportional to velocity. Very, very important. It's not constant. If velocity increases, force increases. Velocity decreases, force decreases. It's proportional to the velocity. Very, very important. Why is the drag force there? Very important. Look at these layers. These layers basically slide over each other. Do you now remember Newton's law of viscosity? When you had layers of fluid sliding over each other, there was a drag force. So that's the exact reason why the layers which are sliding over each other of the wind, which is basically created because of the ball being thrown, that's the reason why this drag force exists. The molecules of air or the fluid will hit against the ball. They will resist it. They will try to stop it. There will be a loss of energy. They will create heat. It's complete loss of energy. That's why the drag force is there. I hope that makes sense. So the drag force is given by 6 pi eta RV. In your books, you might see the symbol minus. Don't get scared again. It just signifies that the direction is opposite. Nothing else. Perfecto. Very good, Vivek. And here comes the question. This is a very interesting question. Yes, Afaf, I did recognize you, Bacha. I did recognize you. Welcome. So we have an experiment. A small steel ball falls through a liquid at a constant speed of 10 centimeters per second. If the ball is now pulled up with a force twice the weight, then how fast will it move up? Amazing logical reasoning question. Okay. So no, it's because of practice, it's because of consistency, and when you have continuous practice and you have that dedication, you will always remember it. So it's just like saying the same song, like the school prayer. Why do you remember the school prayer? Because you do it every day. But maybe you hear one song randomly somewhere, then you might not remember it unless it's very interesting. So when you combine interest and repetition, that is practice, then for sure you'll remember it. Okay, so what do we have? We have a ball, all right. So that ball has its own weight, W, and it is thrown down like this with some velocity. Okay, or it's falling down at a constant speed. If it is falling down at constant speed, that means acceleration is 0. That means the drag force or viscous force should be equal to the weight. And what is drag force equal to? Drag force is 6 pi eta RV. That's what I told you. Fair enough. Now in the second scenario, when the same ball is pulled up with a force twice the weight. Interesting. So you pull the ball up with a force twice the weight. So obviously you will have the weight down. So if one weight is down, 2 times the weight is up, net force is up. So obviously the new velocity will be up and there will be a new drag force down. So F prime drag will be down and this will be some new velocity. Everybody agrees with this? Everybody agrees with this? So let's see what happens. So if we want to find this new velocity, again the acceleration is 0. Let's just figure this out. 2W minus W minus F prime drag is basically 0 because no acceleration. 2W minus W, that's W. And take this guy over there, so it will become F prime drag. And F prime drag is 6 pi eta R new velocity. And W from here is just 6 pi eta R V. This V and this V1 should now be equal. Do you see that? V is equal to V1 because everything else gets cancelled. That means it should still be how much? 10 centimeters per second. So that's the answer. It has not changed. So what has happened? In the first case, speed was down, drag force was up. Next case, net force was up, external forces. So net velocity was up, so drag force opposed it, down. Coincidentally, both the drag forces came out to be the same, and that's why velocity will also be the same. Beautiful question. So it was just about framing those equations, framing those two scenarios, and then writing those equations down. Perfecto. Let's talk about the next thing. Anybody experienced skydiving? Have you? And have you also wondered why does a raindrop not continuously accelerate? Once the rain drops fall from a cloud, it does not continuously accelerate, believe me. If it did, then the velocity of the raindrop will be in kilometers per second. Yeah, because look at the height, look at the acceleration. Within no time, it will gather so much of speed. The speed will be so much that when it hits your head will be blown out, because water at that speed, it's dangerous. So what is that? That basically stops any object from accelerating infinitely for a long time. That is the drag force. Just like these skydivers, I know they have parachutes, but even with the parachute or even without the parachute, their velocity does not continuously increases. Yes, it increases till a certain time, and after that it remains constant because the drag force will oppose their motion. And once the drag force opposes the motion, that's it. You will see there will be a time when the drag force up and the net force down will be equal. So if the drag which is up and the weight which is down, if they are cancelling each other, what is the net force? Net force, 0, right? So if net force is 0, what's the acceleration? Think 0. If acceleration is 0, what's the velocity? Obviously constant, and that's why it's called as the terminal velocity. I know you have the Palm Jumeirah down there. It's a beautiful view. I wish I could do it when I went to Dubai, but yes, I did not have time. It's beautiful island out there, Palm Jumeirah. Now, the whole idea about terminal velocity is when your drag force eventually balances out the other forces, then the body stops accelerating and it goes with constant velocity. That constant velocity is called as the terminal velocity. So look at this. Look at these stones thrown in a long liquid column. Sharan, even 1/4 of the syllabus is enough. If you do 1/4 syllabus, you will be able to score 1/4 marks. If you do 3/4 syllabus, you will get 3/4 marks. If you do complete syllabus, you have a good chance of getting full marks. So everything is fine. You can do half the syllabus also, bacha. So accordingly, your rank will also depend on that. So that's why always when you have time, use this time to do the complete syllabus. So you will see that the terminal velocity is different for different objects because the size, shape might matter. And that's what we want to see. So how does the terminal velocity depend on the size, shape, etc.? So if I ask you that there is a ball which is thrown in a viscous fluid, and what are the forces acting on it? There will be, I think, obviously the weight of the ball. So the force of gravity, which is nothing but the weight of the ball. Then which other force? Buoyant force is also there, right? I know it could be negligible, but let's just say it is being considered. So you will have the buoyant force, the upthrust force, so FB of the fluid, and because the velocity is down, this is the terminal velocity which is down, the drag force will be up, so the viscous force, you can see that this is the viscous force, will be also upwards. Eventually, when the velocity is terminal, the acceleration will be 0. It will stop accelerating. So, can I say when, okay, I will just make a graph over here. This is how the velocity will increase and it will become stagnant. This is basically your terminal velocity. So this is velocity with time. It will start from 0. Eventually it will stop accelerating, and you can also see when you draw a tangent to that, the slope, which is basically acceleration, is 0 eventually. So at terminal velocity, I can say that the net force is 0. So downward force will be balanced by upward force. So gravitational force will be balanced by the viscous force plus the buoyant force. And what is the gravitational force? Gravitational force is nothing but mg. What is the viscous force? 6 pi eta rv. What is the buoyant force? Buoyant force is v rho g. V is the volume of the object into rho of the fluid into g. Now, if you want, you can further, express this in terms of radius. Like volume is nothing but 4 by 3 pi r cube. And mass, you can write it as density This is of the drop, so density of that solid, okay, into volume. So this volume you can further write it as 4 by 3 again pi r cube. Now when you solve this, you are going to see that there is pi here, pi here, pi here, r is there here, here, here. Most of the things will get cancelled, and eventually you are going to get the velocity. Resists acceleration like friction, but it is not following the laws of friction, Suchi Mama. It is like friction, drag, but it is not friction. Okay. Now, when you solve this, you get the final terminal velocity formula, because this V is nothing but the terminal velocity, and guess what it is? Okay. So, the formula looks very interesting. Remember, what is the symbol which is very similar to 9 of all the alphabets? A, B, C, D, E, F, G. So put a G here and put 2 over here, 2 by 9, remember that factor, 2 by 9. It should be in your head. 2 by 9 eta, 9 ta. Just remember that, 9 eta. So that's it. And then you have R. Think about it, square will be there, and you will have the difference of density. So the solid's density minus the fluid's density. So that's the formula. 2 square, 2 is also there, R square is also there. G is similar to 9 and 9 eta, remember it. So 2 by 9 G R square, difference of the density by 9 eta. That's the answer. Okay, so what has happened? When the ball accelerates, okay, there is continuous increase of velocity. Eventually, you will see that the drag force will balance, it will increase, because remember drag force is proportional to velocity. It will increase so much that the weight will be balanced by buoyant force and the viscous force. So once the downward and the upward forces are balancing out, then it reaches something called as the terminal velocity. That means it remains constant. If it remains constant, that's it. You can equate the forces. Gravitational force is mg, mass is density into volume, volume is 4 by 3 pi r cube. Drag force is 6 pi eta rv, Stokes Law. Buoyant force is v rho g, volume is again 4 by 3 pi r cube. Solve this, you will get the answer. This much you will be able to do. This much you will be able to do. You will be able to solve this equation. This is very easy, my warriors. Okay? Perfecto. So, I have put up all the terms just for you, just in case you need it, and you can solve this and you will see the terminal velocity will be 2 by 9, G is also there, R square, difference of the density. Perfect? Alright, and I have also shown you the graph. The graph looks something like this. Velocity increases, and then it stops increasing, it becomes constant. That is called terminal velocity. That is called terminal velocity. Here we go to the first question coming up on your screen. No, if you just use Fg and what is that, Gv, viscous force, no, then you will be missing out on one term. Let me tell you, if you miss the buoyant force, then you will not get this term. Then you will only have this. Okay, you will not get difference. So that if you see that the outside density is very less, like air, then you can neglect it. But if the outside density is more, then you cannot neglect it. So buoyant force cannot be neglected. So density of liquid will also come. Understood? Yeah. So you need to remember this. Direct questions do come in JEE Mains as well as advanced. So you need to remember this. There is no option out of it. You need to know this. Got it? Very good. A small sphere falls from rest in a viscous liquid. Due to friction, heat is produced. Find the relationship between the rate of production of heat and the radius of the sphere at terminal velocity. Let's see how many of you can think about it. What did I tell you? Drag force basically is a non-conservative force. I'll just repeat, drag force is a non-conservative force or viscous force. Viscous or basically drag, I told you it is non-conservative force. If it is a non-conservative force, obviously it will cause loss of energy. So whenever it causes loss of energy, it will produce heat. Interesting. So I want to find out what is the rate at which the heat is produced. So basically power loss. So the power loss will be the force, which is the viscous force, into the velocity. Power is force dot velocity. Everybody remembers this? F into V is power. Acha. So basically the question is asking you what is the power loss proportional to which power of the radius. Now just some time back I told you, if you have a sphere of radius r and if it is falling down with terminal velocity v, the terminal velocity formula is 2 by 9. I told you what is similar to 9? G. And with 9 what do you get? 9 ta, 9 eta. And then you have, because 2 over here, r square, 2 and 2, and then difference of the densities. Correct? Density of solid minus density of fluid. So from here, let's see what and all we can get. First of all, what is the drag force? The drag force is 6 pi eta r v. Correct? The viscous force is 6 pi eta r v, and this v will also come over here. So this will become 6 pi eta r v square. Correct? Now from here, do you see velocity is directly proportional to which power of r? Which power of r, my warriors? It is proportional to r square. Velocity is proportional to r square. That means this thing over here, this power loss, it is directly proportional to r and v square, and v square will be proportional to, think about it, v square will be proportional to r raised to 4. So basically it is proportional to r and r raised to 4. R and r raised to 4 means r raised to 5. So hence the answer is option A. Done, done. So what has happened? The power formula from 11th standard in work power energy. So we are using that. The rate at which heat will be lost will be only because of the drag force. Drag force into velocity. Use Stokes Law. So 6 pi eta rv. Okay. Why is V equal to Vt? It's given. A small sphere falls from rest in a viscous fluid. Due to friction, heat is produced. Find the relationship between the radius and at terminal velocity. It's given. So that's why V is equal to Vt. Make sense? It's given over here. Yep. Very good. Chalo. Let's move on to the next one. Option A is correct. Next question. I want you to get the hang of the formulas through these questions. That's why I'm making sure I solve these questions in front of you. Terminal speed of a sphere which is made of gold, density given, is 0.2. In a liquid of density this much. If you have the sphere of silver, same size, then what do you think is the terminal speed? Okay. So first let's write down the formula for terminal velocity. Only then I'll proceed. Terminal velocity is 2 by 9, I told you. 9 is similar to G, 9 eta, and then you have R square, and then difference of density. Density of solid minus density of liquid. Fair enough. What and all is same? Let's understand that. R is same because same size. That means R is same. And eta is also same liquid. That means eta is also same. Fair enough. G is obviously same. Obviously G is G. So let's see, 2 by 9 is a constant. That means terminal velocity of gold by terminal velocity of silver will have which all terms? G will not be there, eta won't be there, 2 won't be there, 9 won't be there, R will not be there. All these terms will vanish because when you take a ratio, they will anyways get cancelled out, top and bottom. So it won't be there. So what will you have? Density of gold minus density of liquid is same, upon density of silver minus density of liquid again. Correcto? That's all that you will have, nothing else. So what is the terminal speed of gold? Sphere, that is 0.2. Terminal speed of silver, that's what I need to find. Gold's density 19.5 minus liquid's density 1.5 divided by density of silver, that's 10.5 minus 1.5. So this will become 18, this will become 9, so this will become 2. So naturally shift it over there. So V terminal silver. So V terminal silver will be 0.2 divided by 2, which is 0.1 meters per second. Is it there somewhere? Yes, it is. Option C. Very good, Sudarshan. Yep. So Shiva, I just had 12th class session yesterday and we are going to have it tomorrow. So it's there. Don't worry about it. I think you have missed the yesterday's class. So make sure you watch yesterday's class, 12th standard sprint class. And tomorrow also we are going to have it. And Pathfinder will start next week. I'm waiting for bio exam also to be over because some students are also giving bio. Some students have taken PCMB. So I'm just waiting for them. So Monday onwards, you're going to have Pathfinder resumed as well. Okay, Shiva? Chalo. Next question. Two drops of same radius falling through air with same speed, v centimeters per second. If they coalesce, what would be the terminal velocity? What's the meaning of coalesce? If the meaning of coalesce, if the word coalesce is used, it means they merge together. They merge together. So if they merge together, what would be the new speed, terminal speed? Interesting. Let's find this out. So again, let's start with the formula for terminal speed, which is 2 by 9. And then you have G, and then you have eta, and then R square, and then sigma solid minus sigma liquid. Fair enough. If they merge, what happens? Let's see. This is one liquid of radius R. This is another liquid of radius R. If they merge, they form a new liquid of new radius R. The radius won't add. What will add? The volume will add. Correct? The volume will add. So 4 by 3 pi R cube plus 4 by 3 pi R cube will be 4 by 3 pi capital R cube. 4 by 3 pi cancels everywhere. So 2 times of R cube will be R cube. So therefore, cube root of 2 into R is equal to capital R. So I got the new radius. Why do I need that? Look over here. We want to find the new terminal speed. And terminal speed is directly proportional to the square of the radius. That means what I need to do, the new terminal speed upon the old terminal speed will be, because it is proportional to R square, so the new will be proportional to R square and this will be proportional to small r square. So think over here, the new speed I do not know, the old speed is V, R by R. Look from here, what is R by R? R by small r will be cube root of 2. Take small r below, it will be cube root of 2. So basically what you will get is cube root of 2 and whole square. That's what you will get. So basically what is the new speed? It will be V into 2 raised to 2 by 3, which is V raised to 2 raised to 2 is 4. So 4 raised to 1 by 3, which is V cube root of 4. I think that is there over here. Understood? NEET and JEE aspirant, if you just do mechanics and modern physics, for sure you will not clear KVPY. For sure, I'm telling you. You will not even get passing marks. No, not possible. KVPY, even essay. Nope. Yes, Kamut, this is obviously a now live lecture. Okay. So now I'm going to show you the homework questions. This is the first homework question which you need to do. After this class, SK, you need to solve the homework questions, post it in the comment section, and I will read out the names just like I did it at the beginning of the class in the next one. This is your second homework question, Millikan oil drop experiment. Don't get scared. It's based on terminal velocity. And the third one is based on Reynolds number. Let's see if we can get it. And all these answers, you need to post it in the comment section. Now, see, there are a lot of students who know the basics. If you know the basics, what do you need to do? You need to solve problems. Some students probably only know till the boards level. If you know till the boards level, then at least you need to go to the mains level. Some students have studied till the mains level and they want to go to the advanced level. So there are lots of students with different kinds of needs. There are some students who will need KVPY, essay preparation, and like somebody just mentioned, is mechanics and modern physics enough? Obviously it is not enough. You need to practice more. There are KVPY classes right now for all the 11th standard students. Even SX classes are also there. There are classes, my micro courses for advanced problem solving. So my micro courses, so Shreyas sir's micro courses for, erodive classes are there. So erodive is for advanced. Then you have derivations. So derivations is for understanding basics, all the derivations of all the chapter. You have HC Verma class for basics and problem solving. Then you have numerical problem solving class. This is again my classes. Not just mine, other teachers' classes are also there, and you can just get it all on your tablet, on your mobile, or on your laptop. You don't have to run around 10 different institutes, pay money everywhere. For KVPY, this sir. For chemistry, this ma'am. For again JEE, this sir. For boards, test series. For again mains, another coaching institute test series. You don't have to do anything. It's all there in one go. So you get all the batches again in English. You have my micro courses, you get tests, and you get assignments. All of this, you can find it right over here. So if you're watching the video right now, all you need to do is go here, down, okay, I'll pause it, go down over here. Do you see this JEE 2 years course? Okay, avail all exciting Vedantu courses, just click on this. You can change to anything. So let's say for example, you're a class 11 student, you want the KVPY crash course. Click on it, it's there, see this. This is there for, go for this version, go for the classic version. Reason is light and classic, though it looks different over here, but once you click on it, using my coupon code, you get that additional off. Over here, you will also get doubt solving. That's the whole advantage. So just go for this and make sure you join these courses. This is for KVPY. Similar, it's hardly 1,800. You just click on it, enter your details and done. You'll get tests as well. There are 20 mock tests with assignments and recorded classes for all the topics of KVPY. So don't miss this chance because you hardly have any time. Similarly, if you want 11th standard classes, there you go. You have 11th standard classes which also has KVPY. It also has KVPY classes. Okay, just one second. I'll have to just select. Yes. Okay, there you go. It includes KVPY courses as well, including my course. You have 3 versions. Light, classic and plus. Plus gives you mentorship, classic will give you doubt solving, light will give you all the other features which are still there like tests, assignments, classes, everything. Even this is hardly 1,350 rupees, but remember, even though it says 15 days, you get bonus 15 days just because you have used my coupon code SHHPRO. Okay, and also you get the facility of anything, like anything goes wrong, you can always ask me just because you have used my coupon code. And even if you try to buy it for the entire year, it's hardly 54,000 rupees. This is till 2023 last exam. That's a 2-year price. 2-year price. So till the last exam, it might happen July, August, God knows. So that's what it is. So I really hope to see all of you make the best use of this crash courses, KVPY course pro subscription, because the monthly prices are hardly few thousands, which are lesser than your tuition teacher price, who charges you more than this for that to one subject without tests, without assignments. You might think you get personal attention, but actually you get more personal attention in Vedantu than any other institute. Yeah. Navina Poiseuille's formula is not there. It's not there in JEE syllabus. You can see, open up the JEE Mains and Advanced syllabus, you will see it will not be there. Okay, it's deleted. There were times by mistake they put it, but don't worry about it. All right. So thank you so much for being here, and I'm so glad that you have enjoyed this class. And I'm so thankful to all of you who have already supported us by smashing the like button and also hitting the subscribe button. Thank you very much. Take care. And God bless you all. And if you want to know anything, you can definitely ping me on my Instagram handle, Shreyas_Vedantu. Take care. Have a great time. Have your dinner. This was Captain Shreyas and I was going live. Hasta la vista.